Okay guys, so this is going to be the series of copper reactions lab. So what I'm going to do is I'm going to step through this as we go and explain a few things, and then I'm going to go to the lab paper and show you how to do your calculations and your balanced equations and all that good stuff. Okay, so that's not important. This lab is going to be due next Tuesday, April 28th, and this will be the last lab I make you do for the semester. So make sure we get this done on time. Okay, a few things you need to know, lab safety stuff, things that are flammable, acetone's flammable, methanol is flammable. Why is it important to do stuff in the fume hood? In this lab, there's a lot of gases that are involved, like NO2 gas, that can be flammable, and they smell really bad and they can hurt you. So make sure that we do that in the fume hood. We know that the law of conservation of matter says that matter cannot be created or destroyed. It's just, purely transformed from one form to another. Okay. So in this lab, pretty much what we're going to be doing is we are going to start with copper metal. So we all know that copper metal is it's like a reddish, brownish color, if you can see right there. Okay, so that's copper powder. We're going to go through a series of reactions. So we're going to react it with some stuff, we're going to get some products, and then we're going to finally get some copper at the end. Okay, so we're going to go through 5 reactions. And it's going to change forms. This is actually one of the coolest labs we do, but unfortunately you're not able to actually do it in the lab. Okay, so we're going to be using boiling chips. Boiling chips are used to make sure that when things boil, that they boil smoothly. Okay. We're going to be using the word decant in this lab. So decant is just a fancy way for pouring off. Okay, so at some point in time, we're going to be decanting the precipitate, okay, the product, and we're trying to keep the solid in the beaker. Okay, so some other terms that are important. Supernatant liquid is what we're going to be decanting, okay, and the precipitate is going to be your product down here. Okay, so starting the lab. So what we do is we're going to weigh out some copper powder. Okay, and let me look at my lab real quick. So the mass of the empty weighing dish, I believe we're going to label that as number 2 on our data table. The mass of the weighing dish and the copper metal recovered is going to be number 3 on our data table. And to get the mass of the copper that we start with, you're going to do number 3 minus number 2. Okay, there's really not a lot of calculations in this lab. Okay, so what we're going to do first is we're going to take the copper metal and we're going to react it with nitric acid. So when we have nitric acid react with this, it's going to produce a brown nitric oxide gas, NO2 gas. Okay, so we do that under the fume hood. So we're going to keep doing that under the fume hood until it looks like that. Okay, so this is going to be a copper 2 nitrate solution. One of the properties of copper 2 is that when it's in solution, it's blue. Okay, so you're going to answer those questions on your lab. What color is the nitrogen dioxide gas? It's brown. And what color is the copper 2 nitrate solution that remains? Well, it's a light blue. Okay, the next step is we're going to take sodium hydroxide and react it with the copper 2 nitrate. Okay, so you get this flubber looking substance that, it makes a precipitate. What color is the copper 2 hydroxide at the end of the reaction? Well, it's a dark blue. Now, here's the cool part. So what you're going to do is you're going to add some boiling chips. And you're going to start heating this up. Okay, and it's going to start bubbling a little bit, and we're going to get something called, what I like to call, New Orleans water, after Katrina. So you get this copper 2 oxide that's formed that's a dark brown. Okay, so what color is the copper 2 oxide at the end of the reaction? It's a dark brown. Okay, once we do that, we're going to start taking it back to its original substance. Okay, so if I take the copper 2 oxide and mix it with sulfuric acid, it's going to give you copper 2 sulfate. Okay. Oop. Okay, so we go back to this. So you have that copper floating on top, and you have that copper 2 sulfate on the bottom. Now, whenever you take the copper 2 sulfate and you react it with zinc, it's going to fizz a lot. And then we're going to treat it with some methanol and some acetone. Remember that methanol and acetone, those types of compounds, they evaporate quickly and they dry things out quickly. So you're going to stick it in the oven for about 20 minutes, 30 minutes, and it's going to dry out. So the last step of your calculations is you're going to do the mass of the dish and copper metal recovered, the 3.05, and you're going to subtract 2.57 from that, and you get the final mass of your product. Okay. Now, it's important that as we go through these steps, especially after this step where we're going to start pouring off the water, that we don't pour the water off, right after this step, that we don't pour the water off with the product in it, because then we're going to lose the product. And you also need to make sure that whenever you're going through this lab, that we dry things completely, because if it's not dried completely, you're going to get a false reading, and it's going to throw your percentage off for your copper recovery. Okay, so I'm going to switch to this mode right over here. Okay, and so we're going to step through the lab and talk about that. Let me get all my stuff together. Okay, so conservation of matter. We already said that that's super important, that matter cannot be created or destroyed. So we're going to go through these reactions. We already talked about these terms. Boiling chips they make even boiling. Okay, boiling smoothly. Decant means to pour off. Precipitate is an insoluble solid formed by two liquids. Supernatant is what we're going to pour off. Okay, so these are the steps of the reaction. So you can read through that, pretty much talk through that. Okay, so I'm not going to do all of these questions because I've pretty much already answered these. What color is the nitrogen dioxide gas that's evolved in reaction number 1? Well, it was brown. Okay. What color is the copper 2 nitrate solution that is produced in reaction 1? It's a light blue. Okay, so when we go to do our reaction, it says we're going to take copper metal and I'm going to react it with nitric acid. Okay. Based upon our activity series, copper is more reactive than hydrogen. Okay. Now, it gives us the words, okay, of what it's going to break down into, so you don't have to really predict a lot in this lab. Okay, so it says it's going to produce copper 2 nitrate. Copper 2 is Cu with a +2 charge. Nitrate's NO3 with a -1 charge. We're going to crisscross. Plus nitrogen dioxide, which is NO2. And water. Okay, this one's super tricky to balance. It took me a little bit to balance this one. So you to balance this, I'm just gonna pretty much give you this one. It's tricky. So you have 2 ends on this side, 1 end on this side. So what happens is if I want to double this, I'm going to double that. I'm going to double that. And I'll put a 4 right there. So 4 H's, 4 H's. 2 ends here, 2 ends here. That's 4 total. 4 total. And then I have 12 oxygens total. I get 6 here, 4 here. That's 10 plus 2 is 12. Okay? What color is the copper 2 hydroxide solution that is produced in reaction 2? It's that dark blue, flubber looking. Now it says write a balanced equation. So it says we're going to take copper 2 nitrate, and I'm going to react it with sodium hydroxide. Okay. Now it says it's going to form a precipitate of copper 2 hydroxide okay, and sodium nitrate, which is Na with a +1 charge. Nitrate is NO3 with a -1 charge. Okay, so now we got a balance. 2 OHs on this side, 2 OHs on this side, 2 NAs, 2 NAs, 2 NO3s, 2 NO3s, and it's balanced. Okay, so what color is the copper 2 oxide that's formed in reaction 3? We said it was a dark brown. Precipitate, decant, that's all in your lab that you can define. If you're not careful when decanting, what can happen? You can pour the product down the drain. Okay, let's go through the reaction. Okay, so we're going to take, so this is actually written backwards, so don't freak out. So it says copper 2 oxide and water are produced when copper 2 hydroxide is decomposed with heat. So copper 2 hydroxide is Cu with a +2 charge, -1, and I'm going to decompose it, okay, into copper 2 oxide and water. Okay, when I break a metallic hydroxide down, it produces a metallic oxide plus water. Now when I go to balance it, 2 H's, 2 H's, 2 O's, 2 O's, 1 Cu, 1 Cu, and it's balanced. Okay. What color is the copper 2 solution, copper 2 sulfate solution that is produced in reaction 4? So it's going to be the dark brown, it's going to be the solid on top and light blue on bottom. Remember, we convert that back to the light blue. Okay, so it says copper 2 sulfate and water are produced when copper 2 oxide is dissolved by sulfuric acid. So once again, we're going to work backwards on this. Copper 2 oxide plus sulfuric acid is H2SO4. And it's going to produce copper 2 sulfate and water. Okay, and then we're going to make sure it's balanced. 1 Cu, 1 Cu, 1 sulfate, 2 hydrogens, 2 hydrogens, 1 oxygen, you're done. Okay, so these questions can be answered on your own. Why should most of this test be performed in the fume hood? Because they produce harmful gases. We already talked about it. If it's not dried enough, it's going to give you a higher percentage of carbon. It's important that you keep methanol and acetone away from flames because they are flammable. Okay. Number 4, you can do on your own. So it says, if all the steps in the series of chemical reactions of the experiment were performed without error or any loss of material, why should the mass of the copper metal be the same as the beginning of the experiment? So law of conservation of matter and mass says that matter and mass cannot be created nor destroyed. So something along those lines is what you need to write. Okay, our last reaction. It says zinc metal reacts with copper 2 sulfate. Okay, and if we use our activity series, zinc is more active than copper. So they're going to kick each other out. Zinc always has a +2 charge. Sulfate always has a -2 charge, plus copper metal. So that's how we get our final product, is by this reaction right here. And it should be balanced. Okay, just FYI, when we're doing the recovery of the copper mass. So we're going to label this number 1, number 2, number 3, number 4, and number 5. Okay. So, like I said before, let's just go through this. Keep flipping. Okay. So this data right here, okay? This is going to be your number 3. The 0.74 is going to be your number 2. Okay? So to get number 1, you're going to subtract number 3 minus number 2. Like that. Okay? And then for 4 and 5, you get 4 and 5 from the back of the lab. Okay? So to get number 4, you're going to subtract 3.05 minus 2.57. Okay? So that's how you get number 4. And the percent of the copper recovered is going to be number 4 over number 1. Okay, so you should get a number close to 90-something%. Okay? So I would like for you to make sure that all of this is turned in by next Tuesday, April 28th, if we're in spring 2020. And hopefully this helped you out, especially on the writing the reactions portion. But you should be okay with that now since you just took a test over it. If you have any questions, feel free to reach out and let me know if you need help. Thanks, and have a great day.